Now let's say that we have a sample of 9 people, and we have the high school GPAs and the college GPAs of not the 9 people in the sample. These are actually the same 9 high school GPAs and the same 9 college GPAs that I showed you before when we calculated the standard deviations. So we can actually get the standard deviation that we had before for high school GPA. The standard deviation of the sample came out to 0.69. That was the square root of our sample variance of 0.47. Let's put that down here. Let's say that the sample standard deviation equals, well, what did it equal? About 0.69. We'll round it to 2 places for right now. What about for college GPAs? Those are the same 9 college GPAs that I was using before, and their standard deviation of the sample was about 1.06. The letter S stands for sample standard deviation. That's why I'm using the letter S. We're pretending, or we're imagining that this is a sample of 9 people. Now let's create a scatter plot. Actually, first, let's find out what the means are. When we calculated the means before, the mean of the 9 high school GPAs came out to 2, and the mean of the college GPAs also came out to 2. So if you add these 9 numbers and divide the total by 9, you get 2. If you add these 9 numbers and divide the total by 9, you get 2. The symbol for a sample mean is actually an x with a bar above it. It's called x bar. It's 2 here. It's 2 here. They both came out to 2. Now let's plot these numbers on the scatter plot. Person 1, well, let's say that we want to, the reason that we're collecting the data is because we want to see if we can use people's high school GPAs to predict what their college GPAs will end up being. If our goal is to use high school GPA to predict college GPA, what you're using to make the predictions goes down here on the x-axis. And what's being predicted goes on the y-axis. So predicting college GPA, so college GPA will go up here. Since this is on the x-axis, we could call this the x variable. And since college GPA is on the y-axis, we could call it the y variable. Now let's start with person 1. The person has a high school GPA of 1.5, which is right here, and a college GPA of 3, which is up here. So 1.5 and 3 meet right here. Next person has a high school GPA of 3 and a college GPA of 4. 3 is here. You go up to 4 on the y-axis. 4 is over here. Next person, person 3, had a high school GPA of 2 and a college GPA of 3. Next person was 1 and 1. Next person had a high school GPA of 1.5 and a college GPA of only 0.5. And 2.5. 1.5 and 1.5 is right here. 3 and 2 is right here. And 2 and 2 is right here. We can see that we have a positive correlation here because if we drew a circle around this cloud of dots in here, we would have a rising circle. See it rises from left to right. We have some empty area down here, and some empty area up here. It rises from left to right, which means if we wanted to put a line in here to show what type of correlation we have, we would put a rising line in here. Now, how do we actually find out the exact line that we need to go through here? There's actually a way to calculate that line using some of the values that we already have. One thing that we need is the correlation coefficient. The correlation coefficient is a value that tells you whether the correlation is positive or negative, and it also tells you how strong the correlation is. It goes from -1, which is a perfect negative correlation, up to +1, which is a perfect positive correlation, and 0 is no correlation. Let's go to Excel to find out what the correlation coefficient equals. Since we're not calculating correlation coefficients by hand in this class. Let's enter in all of our data. We have 1.5 and 1.5. We had 3 and 4, 2 and 3. The next one was 3. Next one was 1 and 1. Then we had 1.5 and 0.5. Next we have 2.5 and 2.5. And then it looks like 1.5 and 1.5. Then we had 3 and 2 and 2 and 2. Now let's leave this empty box down here. This is where the correlation coefficient will go into. We go to formulas, we go to more functions, we go to statistical. CORREL is correlation coefficient. For array 1, we enter in these numbers, the x numbers. We enter in the y numbers for array 2. I clicked on array 2 and highlighted the B column. And I click OK, and it's 0.75. Make sure that before you do this, you don't have one of the numbers highlighted in here, because if you do, it actually won't calculate the value for you. You have to have an empty cell highlighted that your answer can go into. So correlation coefficient is 0.75. The correlation coefficient of a sample is the letter R. So R equals 0.75. Now what do we do? Well, since this is our x variable, people usually write this as Sx when they're doing a scatter plot like this, and the y column becomes Sy. These are just more specific symbols. X bar is the mean of the x variable column, and in this topic that we're going into right now, we can actually substitute y bar for the mean of the y column. So this is a sample mean, and this is also a sample mean, but this is used when you're finding the mean of the x values. This is used when you're finding the mean of the y values. They're both sample means because all of this data comes from a sample of 9 people and not an entire population. So in order to have a straight line in a graph, you need to have a slope and you need to have a y-intercept. Let's find out the formula for our slope here. In a scatter plot, the formula is slope equals the correlation value, the correlation coefficient, which is R, times Sy over Sx. If we substitute the values, we get 0.75 times Sy is 1.06 up here, and Sx is 0.69 down here. These are just the two standard deviations that we actually calculated by hand. The top one is a standard deviation of the y variable, which is college GPA. The bottom one is a standard deviation of the x variable, which is the high school GPAs. Let's start by dividing 1.06 by 0.69. We get about 1.54. Let's keep it to 2 decimal places. We don't want to round too much while we're still going through the steps of the calculations. Now we have 0.75 times 1.54. Which equals 1.55. Actually 1.555. We'll just leave it this way. 1.155. We'll probably round this off a little bit later. This is our slope. A straight line also has a y-intercept. A straight line also has a y-intercept, and the formula for a scatter plot is the mean of the y values, which is y bar, minus the slope, which is actually the letter b is used for the slope, and multiplied by the mean of the x values, which is x bar. So b is the slope. I know this is a little bit probably confusing because in algebra b is the intercept, but in this formula, in statistics, they use b for slope when you're dealing with a scatter plot. Let's find out what this equals. The mean of the y values is 2 minus the slope, which was 1.155 times the mean of the x values, which was 2 right here. The first step is to multiply 1.155 times 2, which equals 2.31. Move this up here. So 2.31 you have to subtract 2 by 2.31, and we get negative 0.31. So the y-intercept actually comes out to a negative number. And I want to check Excel to see if this is actually true. I'll create a scatter plot in Excel. Formulas. Insert. Scatter. We can, if we go right here, we can put the arrow above one of the dots, click on the right side of the mouse, and it highlights these, and then go to Add Trend Line. Display, well, let's just say linear, because we want the straight line, so it comes in like this, and it actually, if it kept going down and down like this, it would actually meet the y-axis at negative 0.31, because it has a negative y-intercept. So what can we do with that? Well, we could just let's see. The slope is 1.155. Let's actually start at 0 right here. Let's find out what actually, sorry. I'm going to try to think of what to do with this, because I don't want you to have to draw a negative part of the graph down here. I'll just have you start at 0.5. So if we go y equals 0.5, no, we have to have our slope, which was 1.55 times 0.5, which is x, and then our y-intercept at the end, which was a negative 0.31. Let's multiply this. We're multiplying and subtracting. We get 0.2675. So when x is 0.5, y is 0.2675. Let's actually go right up to 3 right here, or maybe 3.5, because then we have, this is right below the lowest, the furthest dot to the left. This is right above the furthest dot to the right. So it's y equals 1.155, the slope, times 3.5 minus 0.31. What does this equal? 1.55 times 3.5 is 4.04, about, minus 0.31, which gives us 3.73. So we plugged in a value for x right here. We plugged in a value for x right here. When x was 0.5, we got about 0.26 for y, which is about in here. So let's make a dot right about there. I'm going to make it a different color so I remember what it is. It's not one of the data values. When x was 3.5, y was about 3.73, which is about up here. Let's move over here. Make a dot right there. Now let's just make a straight line connecting these two dots. This is our line that goes through the scatter plot and shows our correlation. And it's called the regression line. Let's see if the regression line looks about the same in this scatter plot. It goes through those 4 dots right there. Ours is pretty much the same. This is just, I didn't draw this perfectly, so this dot is a little bit off, but this is pretty much what Excel gave us. The usefulness of this line is to actually make predictions for other people who are outside of your sample. So by collecting this data and doing these calculations, you've actually created an equation that can be used to make predictions for other people outside of these 9 people. So if there was a 10th person who came along, and that person told us that his or her high school GPA was a 2.5, and maybe they didn't go to college yet, so their college GPA is still unknown. We now want to be able to predict this person's college GPA in the future. What we did up here was we found 9 people who had already graduated from college, and we were able to record their high school GPAs and their college GPAs. And we were able to look at the correlation between high school GPA and college GPA. And now we have a person who's only graduated from high school and hasn't gone to college yet. And we want to use the person's high school GPA to predict the college GPA. This line that we have now can help us do that. We can at least make a rough prediction, because if we start at this person's high school GPA, which is 2.5, and we go up to the line up here, the prediction is just whatever is straight over here on the y-axis. So it's going to tell us to predict about 0.25 for college GPA, it seems like. Let's see if the prediction actually does come out that way. So we're going to use, for our y-intercept, we actually use the letter A. And now we have an equation. It's going to look like this. Y hat. Sorry about all of the symbols. Y hat is actually predicted Y, not actual Y. So it's the person's predicted college GPA. And it equals the slope, which is B, times X, which is the person's college GPA, which we actually know, minus the y-intercept of A. What this is called is a regression equation. It's used for making these predictions. So it's y equals the slope, which is 1.155, times x, which is 2.5. The person's college GPA is 2.5. Minus our y-intercept, which is a 0.31. Since the y-intercept is negative, we're subtracting it. I mean, it's a subtraction sign and not an addition sign. Technically, it's also just adding a negative number at the end. So let's do this part first. 1.155 times 2.5, which is the high school GPA that we already know, and it comes out to about 2.8875. Minus 0.31. Which is about 2.58. So y hat, which is the predicted y value, is 2.58. In this case, our predicted college GPA is 2.58. So if a person, according to this equation, if a person tells us that they have a high school GPA of 2.5, we would predict that person's college GPA to be 2.58. This equation tells us that if a person has a high school GPA of 2.5, we should predict that they will go on to get a college GPA of about 2.58. The y variable is college GPA, so these are the y values, the college GPAs, or the y values. This is actually a predicted y value. So in our example, it's a predicted college GPA. So we had, I said this was called a regression equation. It's the equation for predicting x based on y. Sorry, I didn't say that right. Predicting y based on x, or using x to predict y. And it kind of makes sense that this would be the prediction, because it's we can see that this, according to our correlation, or according to the way the dots are rising from left to right, it does look like the typical person with a high school GPA of 2.5 would end up with a college GPA of about 2.5. Because if we look at the cloud of dots, like I said, you can draw a cloud, a circle around the dots. When high school GPA gets up to 2.5 in our data set, the middle of this area right here, above 2.5, is about 2.5 over here. So it does seem like the typical high school graduate with a college, it does seem like the typical high school graduate who got a 2.5 high school GPA would have about a college GPA of about 2.5. This red line here goes to about the center in here of this cloud of dots. And what if the correlation was negative? What if the line was dropping like this? What we would have in that case is we would have a negative correlation coefficient. R would be negative, which would mean that the slope would end up being negative when you use this formula. And that would mean that this value, this slope, in the regression equation would be a negative number. What would we do in that case? Well, if you had a negative slope, you would just multiply by the negative slope, and you would get a negative number, and then you just add the intercept. So what if we had a negative slope and a positive y-intercept? What would we do? Let's say x is 2. We're plugging in 2 to predict y. Well, negative 1.5 times 2 is negative 3. So we would have a negative 3 here. We would just add the y-intercept of plus 3.1. And we would get our answer of 0.1. That would be the prediction. What if the slope and y-intercept were negative? Well, then you would still get a negative number here. If you plug in a positive x, you multiply a positive by a negative, you get a negative number. And then we would have to actually subtract a negative number. What I mean is we would actually have to add a negative number to another negative number. So it would be negative 3 plus negative 3.1. Or you could just say negative 3 minus 3.1. In order to do that, you actually add the two numbers. 3 plus 3.1 is 6.1, but you change it to a negative. So it would be negative 6.1. That would be the prediction.